we will use the LOGEST, LINEST, and Matrix Solution for power law decay regression. We start with the chart. Here you have a chart where you have power law, which is y equals a times b to the power x. We'll calculate the coefficients a and b using the LOGEST function. So we set this aside and we'll use the LOGEST function. We'll use the LOGEST function of this dataset. We have the dataset for y and x. So our coefficients a and b are 2.937 and 0.7 respectively. So we will write the equation that is 2. We'll just round it up as 94 times b, which is 0.74 to the power x. So this is equal to 2.94 times 0.74 to the power x. And we show this estimated data set into the chart. Add a series and use this range. So this is the trend line in red, which is the estimated value of y, which is 2.94 times 0.74 to the power x. We'll complete the LOGEST function, the statistics of the LOGEST function, by inserting 1, 1. So we have the 10 outputs. These 10 outputs can be calculated using the LINEST. To do that, we have to transform our dataset into the linear form. So starting with the equation, y equals a to the power times b to the power x. In the linear form, it will be ln y equals ln a plus, and the logarithm of b to the power x will be x times ln b. Factoring out, you will have two factors. We have 1 comma ln 1 comma x, that's the 1 comma x matrix, which is this, times ln a semicolon ln b matrix, which is this matrix. We'll calculate this matrix using the matrix solution, or these values using the matrix solution. Let's start with the transforming the y values, which is our formula, ln of the y values. Then complete the 1 comma x matrix. We start with the 1 column and the x column, which is our formula of the x values. Now we can use the LINEST because we have transformed the dataset into the linear form. We have LINEST of data y and data x, and we show the full statistics. Our coefficients are different, but our standard error values of the coefficients are the same. R square and stay x, they are the same. F statistics and degrees of freedom are the same. Our regression sum of square and residual sum of square, they are the same. But this one is the logarithm of our LOGEST output. So let's test that. We use ln of b. So this is ln of b, matches to our LINEST output. And this is ln of a. ln of a, which matches to our LINEST output. So our b0 is b a and b1 is b. We can use the slope for this. Data y and data x. And it matches our LINEST output. You can also use intercept. Data y and data x. We can calculate the r squared. Data y and data x. And it matches to our LINEST and LOGEST output. Can calculate the stay x. Data y and data x. And this matches to our LINEST and LOGEST output. We can calculate for the others, which start with the rows or the population. That is the rows of the range. That's 14. Now we can calculate the degrees of freedom of the denominator, which is rows minus columns of the range. Columns of the range, of data set range. 12. And this matches to our LINEST and LOGEST output. We can now calculate for the residual sum of square, which is degrees of freedom times stay x to the power 2, or stay x squared. 0.37 matches to our LINEST and LOGEST output. We calculate for the regression sum of square, which is r squared times n times variance of varp of the L and Y values. 14.36 matches to our LINEST and LOGEST output. The F statistics, which is equal to regression sum of square divided by 1, because there's only one independent variable, there's only one set of independent variable, divided by stay x squared to the power 2. 465.06 matches to our LINEST and LOGEST output. Then we calculate for these last two. We begin with the Peter input inverse, which is equal to min inverse m mod transpose of the X matrix at itself. Now we can calculate for the standard error of B0, which is equal to stay X times square root of P0 1. 0.074 matches to our LINEST and LOGEST output. And standard error value of coefficient B1, which is again stay X times square root of P0 2. 0.01411 matches to our LINEST and LOGEST output. We can continue calculating for the these values of ln b0 and b1. We begin with the b0 in a cofactor, which is m mod transpose of this matrix, the 1x matrix, and the y values. Now we can calculate the coefficients ln a and ln b, which is equal to m mod of p0 in a inverse and the p0 in a cofactor. This matches to our LINEST output. So B ln A matches to our ln B0 LINEST, ln B matches to ln B1 of our LINEST. Then we can calculate for b, which is exponent of ln and this matches to our logest output and exponent ln and this matches to our logest output. This completes the logest, LINEST, and matrix solution for power law decay model